All right, this lab is divided into two parts, and the first part is looking at the potential energy stored in an object because of its position. So we're looking at the gravitational energy stored in an object. Now remember that has to do with height. So what you're going to do, you have a table, a floor, or whatever it is, it doesn't matter, whatever you're measuring from. So here's our table. This is my reference point. So right now we are 0 anything above our reference point. We have 0 potential energy. You're going to take your mass. Again, it doesn't matter what your mass is. You're not going to change your mass. You're just going to hook it up to your spring scale. Then you're going to take it, lift it up however high you want. Doesn't matter. 10 centimeters. So we take this, lift it up 10 centimeters, and then we're going to measure the force. We're going to lift it up another 10 centimeters, measure the force. Another 10 centimeters, measure the force. Okay, this one's pretty straightforward, but we're looking at how does the distance change from our reference point up. That's what we're changing, so that's our independent variable. That's going to go on our x-axis. And then we're looking at how the gravity force changes as we do that. So since that's going to change because of our height, that's going to be on our y-axis. So that's part one. The second part of this lab is dealing with spring potential energy. So we're looking at how much energy is stored in that spring when it stretches or compresses. So you'll need your spring scale, and you'll need a spring that come with your kit, and the rubber band that's in your kit as well. You also need somewhere to hang your spring. I have these fabulous little hooks up on top of my whiteboard. You probably don't have that. You can hang it on anything, but you want it to be able to hang down, and you want ideally something behind it that you can mark where that spring was to start with. Okay. So the bottom of your spring, while it's just hanging, is going to be your reference point. So right now we have this hanging right here. Right there is our reference point. So if you mark that, this is where, I'm too short. Yeah. So this is our reference point. Right there. Okay. So what you're going to do is you're going to take your spring scale and you're going to hook it onto your spring. And then you're going to stretch your spring. So we're just going to pull it down. And it doesn't matter how much. You can pull it down the same amount if you want. You can pull it down a different amount if you want. If you have a ruler, which I don't know where my rulers are, if you have a ruler, found one. So you can mark this ahead of time, or you can mark it as a stretch later on. It doesn't really matter. So it is kind of easier to do that if you take this and mark, I don't know, let's just say every 5 centimeters for this particular spring. That might vary. Oh, my marker doesn't work either. That might vary depending on what kind of spring you have. Right? So this distance right here is every 5 centimeters. So if I take my spring scale and pull it down 5 centimeters, what you'll see is that it takes a certain amount of force to do that, right? So 5 centimeters, it has, oops, it's upside down, this much force. That's your data. And then you're going to pull it down another 5 centimeters, record the new force. Pull it down another 5 centimeters, record the force, all right? So you're going to do that for each one of your springs and your rubber band. So we're looking at how much force does it take to stretch that spring a certain distance. Since I am changing how much distance that our spring is stretching, that's going to be my independent variable. The amount of force that it takes to do that is going to be my dependent variable. So we're going to have the length of our spring stretched on our x-axis and the amount of force on our y-axis.